Welcome to Get Your FRQ On. This question is from 2012. It is question 6, and it is not calculator active. In the question stem, we have a particle moving along the x-axis for values of t between 0 and 12. The velocity of the particle is given by the function v of t equals cosine of pi t over 6. And we are also given that at t equals 0, the position of the particle is at -2. In part A of the question, we are asked to find when the particle is moving to the left for values of t between 0 and 12. Okay, so for velocity problems like this with particle motion, typically the object is moving to the left when its velocity is negative. We're given a function for the velocity. The velocity is cosine of pi t over 6, so this particle should be moving to the left whenever v of t is less than 0. However, this is not a calculator active question, so we actually have to solve this inequality analytically. So solve the inequality v of t equals cosine of pi 6 t is less than 0. All right, well, cosine of pi over 6 times t is going to equal 0 when pi sixths of t is equal to pi halves, or pi sixths of t is equal to 3 pi halves. And the only solutions to those equations on the interval from 0 to 12 are t equals 3 and t equals 9. So the particle will be moving to the left when t is between 3 and 9, because on that interval cosine pi sixths of t will be negative anywhere between 3 and 9. In part B, we are asked to write an integral expression for the total distance traveled from t equals 0 to t equals 6. Now, one thing that's important to understand about this question is the wording. It is not asking us to find the total displacement between t equals 0 and t equals 6. It is asking for total distance traveled. Total distance traveled is a special integral. That integral involves the absolute value. Right? So the integral we want is the definite integral from 0 to 6 of the absolute value of v of t dt, which you could also write as the integral from 0 to 6 of the absolute value of cosine pi sixths t dt. That's the only thing we need to do for this. We do not need to evaluate it. We just need to write the integral. In part C of the question, we are asked to find the function a of t and then determine if the speed of the particle is increasing or decreasing at t equals 4, and to provide reasoning. So a of t is just going to be the derivative of our velocity function. So a of t is just d dx of cosine pi sixths of t, which, applying the chain rule and some basic differentiation rules, a of t is negative pi sixths of sine pi sixths t. So there's our a of t. Now we have to determine if the speed of the particle is increasing or decreasing at t equals 4. So the way we're going to do this is the speed of the particle will be increasing if a of t and v of t have the same sign at t equals 4, and the speed will be decreasing if they have opposite signs. So what we need to do here is we need to evaluate a of 4 and v of 4 enough to know whether or not they're going to be positive or negative. All right, so a of 4 is going to be negative pi over 6 times the sine of 4 pi sixths, which is 2 pi thirds. Sine of 2 pi thirds is square root 3 over 2. Square root 3 over 2 times negative pi over 6 will be negative because that's a product of a negative number and a positive number, so a of 4 is negative. V of 4 is cosine of 2 pi thirds, or 4 pi sixths if you don't reduce. Cosine of 4 pi sixths is negative 1/2, which is also negative. So from this we see that a of 4 and v of 4 are both negative, and therefore the speed of the particle is increasing at time t equals 4. In part D, we are asked to find the position of the particle at time t equals 4. So this is a fundamental theorem of calculus problem. We have an initial value at time t equals 0. The particle is at position -2. So to find the actual position of the particle at t equals 4, we have to account for that initial value. All right, so that initial position of the particle is -2. From that -2, we are going to add the value of the definite integral from 0 to 4 of our velocity function, which is cosine pi 6 over t. To find this antiderivative, it's not entirely obvious. You can use pattern recognition or maybe u substitution to do this. The antiderivative of cosine pi 6 t is 6 over pi times the sine of pi 6 t. And then I have to evaluate that at 4 and 0, take the difference, and then add the -2 when I am done to get the actual position of this particle at t equals 4. So if I evaluate my antiderivative at 4, I get 6 over pi times the sine of 4 pi 6 minus what is going to amount to the sine of 0. And since sine of 0 is 0, that's just going to disappear. So I'm going to get -2 plus 6 over pi times square root 3 over 2. And that's just going to give me -2 plus 3 square root 3 all over pi. If I want to write that, I don't have to write the last one. I could just leave it as this one right here, since there's no more actual calculus to do. So that would be the position of the particle at t equals 4. So x of 4 is this -2 plus 3 root 3 all over pi. Keep in mind, this is not a calculator active question, so you're going to have some kind of exact answer here. A decimal here would be very suspicious to the readers since it's not a calculator active question.